So as I mentioned yesterday, I thought I might be out today. And so I still want to go over the answers to 12-4 Practice A and also remind you of the concepts of geometric sequences and series that we discussed yesterday. So just to set the stage here, let's remember what a geometric sequence is. A geometric sequence is a sequence that has a first term, let's call it 3, and then a common ratio, meaning that to make the consecutive terms in the sequence, you multiply by a particular number. Let's say my common ratio for this term is 2. Then if my first term is 3, 3 times 2 is 6. If we multiply by 2 again, we get 12. If we multiply by 2 again, we get 24. Multiply 2 again, we get 48, and so on. So this is a geometric series. That common ratio of 2 can be found by dividing any two consecutive terms. 12 divided by 6 is 2, 24 divided by 12 is 2, and so on. So this is a sequence right here. When we talk about the series, we're talking about adding up a certain number of terms. 3 plus 6 plus 12 plus 24 plus 48 plus 48 plus ... So this one here, this would be the series. So that's the gist of the lesson. Now let's get some details about how we're going to compute these values and solve the problems. One of the things we discussed in class was the need to be able to find R, the common ratio. And sometimes we will need to figure out the common ratio when we don't have consecutive terms. So what we said in class was, let's say we just have 2 terms. So we're tooling along in this sequence, and at some point we have the term A sub n, and then there's more terms, and eventually we have the term A sub m. In order to find other terms in this sequence, we have to figure out what the common ratio was. And so we talked about a formula that would help us do this. And our formula was, our formula was R equals, we are going to divide the second term down the row by the first term, so A sub m divided by A sub n, and then we had to do a root of that. And the way we figured out which root to do was we did the top position minus the bottom position. So for example, if the two terms were actually next to each other, like 6 and 12, we would simply do R equals 12 over 6, and since these two are next to each other, that the positions m minus n would be 1. Like let's say this is A1 and this is A2. 2 minus 1 is 1. We'd just be doing a first root, which means we're not doing a root, and so this R would be 2. However, if our terms were, say, 2 apart, like A1 was 3, A2 we did not know, so that's a question mark, and A3 was 27, we would do 27 over 3, and we'd have to do a square root because 3 minus 1 is 2. And this would be our common ratio. Well, 27 divided by 3 is 9, and the square root of 9 is 3, so this would be R equals 3. So this formula becomes important in finding R, and you'll see it in action when I go over the answers to the problems. We also discussed a formula for finding the nth term of a sequence, and this one was very similar to a formula that we had when we were learning arithmetic sequences. We said if you want to know A sub n, that's the nth term. This is the term you want to know. That's going to equal some term that you already know. We've been calling that A sub m. And instead of adding a common difference, we're going to multiply by a common ratio. you know that our common ratio is r. And the way we know how many r's to multiply by is to subtract n minus m and make that the exponent on r. That's a minus sign there. Okay. So if, let's say, my fifth term is 7 and my constant ratio is 3, and I want to know the 10th term. So a sub 10 is the one that I want to know. That's supposed to be a 10. I would write out the formula. A sub 10, the one I want to know, equals 7, which is a sub 5, the one I do know, times 3 to the 10 minus 5 power, which is 3 to the 5th. That 5 is 10 minus 5. Now, I've already done 3 to the 5th on my calculator, and so I happen to know now that that is 243. And when I do 7 times 243, I get 1,701. So in this particular sequence, the 10th term happens to be 1,701. And in general, we can use this formula to find any particular term in a sequence. We usually call that the nth term. All right, let's go through some of the solutions to this worksheet. As we begin the problems, we are asked to decide whether a sequence is geometric or arithmetic. And in problem 1, they're trying to lead us through the process. It does get a little confusing, but in general, what they're asking letter A is, subtract the consecutive terms and see if you get the same common difference. I did a little subtracting. I did 384 minus 768, and I got negative 384. And then I did 192 minus 384, and that was negative 192. And then I did 96 minus 192, and I got negative 96. These are obviously different values. So that tells me that this sequence is not arithmetic. Then they say to find the common ratios. And so what we do is we start dividing. 384 divided by 768, 192 divided by 384, and so on. And here are the values that I came up with when I did that division. Excuse me. For 384 over 768, I ended up with 1/2 or 0.5. For 192 divided by 384, 1/2, 0.5, whichever way you want to write it. 96 divided by 192, you guessed it, 0.5. And 48 divided by 96, also 0.5. Since all of these quotients are the same, we call this our common ratio. Okay? So when I write down my answer for letter C, this is geometric. And I write that R equals 0.5 or 1/2. If you prefer to write the fraction, feel free. And we're going to go through that same process on each of these sequences. In fact, what I'm going to do is I'm going to check the ratios first, just to see if it happens to be geometric right off the bat. For number 2 here, I started right out by checking the ratios, and every time I came up with 2.5. And so 20 divided by 8 is 2.5, 50 divided by 20 is 2.5, and so on. That means this thing is geometric. And my common ratio was 2.5. For number 3, when I divided the consecutive terms, I kept getting different values. The first time I got 0.619, the second time I got 0.384, and I immediately knew that this was not geometric. However, when I subtract the consecutive terms, I keep getting negative 8. So this sequence is arithmetic. And my common difference is negative 8. On number 4, I started dividing, and every time my common ratio was negative 2. So this thing's geometric. And I get R equals negative 2. When I get to number 5, things get a little weird. 2 divided by 1 is 2, and 4 divided by 2 is 2, but 7 divided by 4 is not 2, so this thing's not geometric. But when I subtract the terms, I don't get a common difference either. 2 minus 1 is 1, 4 minus 2 is 2, 7 minus 4 is 3, and so on. So this is neither arithmetic or geometric. It might be something else, but it's not geometric, and it's not arithmetic. When I look at number 6, 10 divided by 5 is 2, 20 divided by 10 is 2, 40 divided by 20 is 2, 80 divided by 40 is 2, 160 divided by 8 is 2. This is always a common ratio of 2, so this is geometric. And that common ratio is positive 2 this time, right? You just divide the consecutive terms. And then for number 7, 2 divided by negative 1 is negative 2. 4 divided by 2 is negative 2. But then we get to 7 divided by negative 4. That is not negative 2. And so this thing's not geometric. And when we subtract these terms, consecutive terms, we get 2 minus negative 1, which is 3. Negative 4 minus 2 is negative 6. 7 minus negative 4 is positive 11. This thing is not arithmetic either, so this is another neither. There is no common difference. There is no common ratio on either of these sequences here. They just happen to be neither. Let's move on. So in the rest of these problems from number 8 to 12, we're trying to find the 10th term, as it says right here. First thing we need to do, as it says in letter A, we need to find a common ratio. Since they are giving us consecutive terms, finding the common ratio is pretty straightforward. We just divide two consecutive terms. So 125 divided by 625. And that works out to be either 1/5 or you could call it 0.2. So I'm going to be multiplying by 0.2 or 1/5 to make the terms in the sequence. Now we are looking for the 10th term, so I know that that's going to be the term I'm looking for, a sub 10. Oops, I put a sub n there. Let's see if I can erase that real quick. There we go. A sub 10, and then just pick any term that we know. If you want to use a sub 1 like they suggest, that's fine. That's going to be 625. And then I'm going to multiply by 0.2 raised to the 9th power, because 10 minus 1 is 9. Since I used a sub 1, I have to do 10 minus 1, which is 9. And then we're just going to type this in the calculator, and when we do that, we end up getting 0.00032. I'm going to have to write that on the side here. 0.00032. 625 times 0.2 to the 9th. The 10th term in this sequence is 0.00032. We're going to play that same game for all of these sequences. So on number 9, my common ratio turns out to be negative 1/2, negative 0.5. Because when you do negative 4,800 divided by 9,600, you get negative 0.5. And that means a sub 10 is 9,600 times negative 0.5 raised to the 9th power. Oh my goodness, that's supposed to be a 9. And it's okay that that turns out to be negative because we're raising this to an odd power, so it's going to be negative. And when I do that, of course, I'm running out of space here again, but I got negative 18.75 for number 9. The common ratio in number 10 is 3, so I'm looking for a sub 10, and that's going to be my first term, which is 1 times my common ratio to the 9th power, because 10 minus 9 is 1, or 10 minus 1 is 9. 3 to the 9th power happens to be 19,683 times 1. In problem 11, the common ratio is R equals 0.1. Because when I do 550 divided by 5,500, I get 0.1. A sub 10 is going to be, let's do it with 55 this time just for kicks. 55 times 0.1. This time we're not going to raise it to the 9th power. This 55 is the third term, so we're going to raise it to the 7th power because 10 minus 3 is 7. And when we do that, we get this crazy decimal. I'm going to squeeze it in here. 0.0000055. So it's interesting. All of these terms have 2 5s in them. It's just a matter of where the decimal place is. Okay, our last geometric sequence happens to be 4 over 81, 4 over 27, 4 over 9, 4 over 3. First thing we need to get is a common ratio. So we're going to divide 4 over 27 by 4 over 81. And so that common ratio works out to be 3, believe it or not. So when we're doing a sub 10, we're going to do a term that we know. Let's pick the 4th term, which is 4 over 3. We're going to do 4 over 3 times 3 raised to the, that is the 4th term, so the 6th power. And when we do 4 over 3 times 3 to the 6th, we get 972. So the 10th term is 972 in this particular sequence. Now, I didn't mention it on the earlier slide, but in class, we talked about the fact that you could find the geometric mean by doing the square root of A times B. So to find the geometric mean in 13 through 15, that's exactly what we're going to do. When you do 10 times 40, you get 400, and the square root of 400 is 20. But we're actually going to indicate both of the square roots. So let's put plus and minus 20. And 3 times 27 is 81, and the square root of 81 is 9. And we're going to include both of the square roots. And 5 times 45 is 225. Negative 5 times negative 45 is 225. The square root of 225 is 15, and we're going to put both square roots. So geometric mean is pretty easy. You're just doing both square roots of whatever the product is of your two values. Before we get to number 16, we're going to need to discuss the formula for the sum of a geometric series, because we're going to have to do that in 16b. So just like we had for arithmetic sequences, we have a formula. What in the world? Why can't I write? We have a formula. There we go. S sub n, which will give us the sum of the first n terms in a series. And that's going to equal the first term, which we always call a sub 1. Geez, why is it doing that? Oh my goodness. Let me hit rewind here. It's doing it again. That is so crazy. I think I'm pushing too hard. A sub 1, thank you. Times, and then we got to make this weird fraction. 1 minus the common ratio, oh jeez, raised to the nth power, same n as the n on the s here, divided by 1 minus the common ratio itself. And this formula is how we add up all the terms, the first n terms of a particular geometric series. It's going to come in handy when we get to number 16. Let's go ahead and just check this out. So in this job, Matthew is making a salary of $20,000. And we're going to basically, oh geez, I can't seem to write here, $20,000 That's going to be our first term. And to get to the next term, we have to do a 5% increase. In other words, we have to multiply by 1.05. If you just multiply by 0.05, you won't get the next term in the sequence. You'll just get the amount of his raise. So after making 20,000 in that first year, when you multiply by 1.05, you find out that he's making 21,000 the next year. Gosh. I don't know why it's making me write like this. And if we multiply by 1.05 again, you find out in the following year he's making $22,050, which looks like this. I'm showing you this because if you wanted to continue to find out what he makes in the 10th year, you could just continue this sequence out. However, we already know that if we're trying to find a sub 10, I don't know why this thing is not writing. I'm having a bad Monday here. A sub n, come on, man. A sub n, there we go. Which for us is a sub 10. So I wrote the wrong thing. Let's write 10. Let's take a term that we know, like 20,000, and multiply by our common ratio of 1.05. And we're going to raise that to the 9th power because 10 minus 1 is 9. And when we do that, we find out that he's going to make in his 10th year $31,026.56 in his 10th year. Let's put a little $sign on there so we know he's actually making money. It will not let me put a $sign on. I am not having a good day with the $signs. There it is. Okay. Now, what were his total earnings over a 10-year period? For that, we need to compute S sub 10 because we want to know the sum of the series of the terms from A1 to A10. And so we'll follow that formula that I put on the screen right before this, which is we need to know the first term, which is 20,000. And then we're going to multiply that by whatever the result of this ratio is. It's 1 minus r, which is 1.05, to the n power. So I'm going to use 10 again. I'm not going to use 9 this time. Oops. That is obviously not the right pen. Let's put a 10 there. And then we're going to divide by 1 minus r, which is 1.05. And you have to be careful how you type this into your calculator. But when you do type it in, and I can help you with that next time we see each other, you should get, over the 10 years, Matthew making $251,000. Oh, come on, man. $557.85. That's the result of typing this formula incorrectly and hitting equals. Okay? So, I hope this helped you understand how we compute the answers for that practice A. What I'm going to have you do now, and I want you to start in class, is practice B, which is going to cover very similar concepts. Good luck with this, and I'll see you soon.